this good now?
Yeah, you're good.
Okay. Hello, everyone. I'm going to talk about Nix and C++. By show of hands, maybe who's never heard about Nix? Who has used Nix? Okay, who's heard about it? Awesome. So yeah, like Justin said, I work here at Nitro, writing C++. But on my home computer, I use NixOS. So it started as a project in 2003, written by Ilko. I forget his last name. In 2006, he wrote a PhD thesis describing all the nice mathematical properties that this new build system had. And back then, it was still a big piece of research code. But since it has evolved and become really fun and easy to use and pretty reliable. And in 2013, I heard about it, installed it on my computer, tried it out. I liked it so much. The next year, I set it up as my main OS. And you can install the Linux packaging system on any Linux distribution, on Mac OS, on Windows Cygwin. But if you install the entire NixOS system, you get even more benefits out of it. So the first time I installed it on my computer, I typed this command and I looked at /bin/user, and basically it's empty. All you have is a shell and an environment and nothing else. And the shell points to this weird path that has a hash in it in /nix/store. It can be very confusing. Can everyone see the slides? Okay. But hopefully after this talk, you'll understand it a little bit better, and you'll know why people still use it, even though it's different. So throughout this talk, I'm going to go through using a sample C++ project with Nix. And the first thing I want to do with this project is build it with CMake in this case. So I run CMake. CMake is not installed on the computer. So nixenv is the package install command. It installs a package locally for a single user. So different users on the same system will see a different set of packages depending on what they install. And so if I install CMake, run it again for this package, I get an error. It couldn't find make, and it couldn't find the C compiler. So I run nixenv again for new make and GCC, and it downloads the missing packages, installs it, and then what nixenv does is it takes all these packages with our different folders and merges them using symlinks into a user environment. So this user environment that gets created is now in my path, and it contains symlinks to all these different applications. So now I can build the project. It finds the C++ compiler. It finds make, but it doesn't find GMP, which is a dependency of this project. So now I could go on and install things locally on my system, but ideally I don't want to bloat my environment with all these dependencies for packages, for projects I just want to build. So I create a developing environment for this package. I put in shell.nix. Nix is also the name of the declarative scripting language to describe packages. And so I describe a package, I put metadata. This package is called lean, the version, and the build inputs. So I did Python and GMP. And now, if I run Nix shell, Nix shell, the second program that comes with Nix, it takes a package, looks at all the development dependencies for that package, and brings you into a shell that has all those dependencies available. So from that shell, I can run CMake, which is now installed, and it will find Python, it will find GMP, which are dependencies of this package, and build it. And it builds it. Any questions so far? Yes?
Can you get that only on NixOS? So this.
No, so far everything is works also on Nix. It's not NixOS specific. I'll try to mention it when it is. But in this environment that I've created, I still have access to the packages I installed in the global environment, in this case, NetHack. I can just play NetHack even though it's not specified as a build dependency. And if not only can I play NetHack, but the CMake script also detects the compiler from outside the shell and not from inside the build environment. But if I run nix shell -- pure, it empties my environment before starting the shell. And now NetHack is not found anymore. And it finds the correct compiler. You can tell the difference here. It found the one in my home. Now it finds the one that was specified in the dependency for the package. So I can take this script that creates a build environment and turn it into a package. And this package will build my entire project. All I have to add at the bottom are these 3 lines. 1, to load the source, tell CMake where it is. And the 3rd line is only necessary because Nix makes everything immutable when it can, everything read-only. But this package writes to the source folder. So I have to schmod it to make it writable. And this is one of the cool things about Nix. Unless you ask for it, you don't get it. Your bin and user folders are completely empty. All your sources are read-only. Packages, when they're built, which I can do now with the nix build command, get built in a sandbox that has no network access, that uses a different mount point, that has nothing else of the system visible except the dependencies that package needs. So if you miss a dependency, or if your package does any networking, it'll fail at the build step if you're in the sandbox. And so with this simple package, everything gets built. The package again, Nix detects that I've passed CMake as a dependency, so it builds it using CMake and generates the build commands for me. And so the package gets built into the store, but the result symlink gets created in the local folder and points to the path in the store for the package. And I can run the lean command using the result symlink here. And if I inspect it, all the libraries that it depends on are listed here, and they're actually linked using RPath, so that no matter where you put it or what libraries are in your environment, running the executable will always use the libraries that it was built with. And then I can run file to see that the result is a symlink to the store, like I said. And oh, nixrun. Nixrun is another command that comes with Nix. You give it a set of packages, and it runs a command where those packages are available. So in this case, I didn't have the file command installed on my computer. Use nixrun, nixpkgs.file, and I can run the command. So far, the default compiler that came with the package, that the package was built with, was GCC. But with nixrun, I can load Clang. And then if Clang is not already installed or downloaded on the computer, nixrun will fetch it. And if it's not available on the remote binary cache, it will get built. In this case, everything was downloaded. Sorry. So what's next? Oh, so GCC, Clang, different versions of Clang, Clang 7, GCC 8. So I think the version of GCC was 5 or 6 earlier. And the reason GCC 8 isn't the default is because not all packages in the Nix ecosystem can build with GCC 8. But someone created a GCC 8 branch for Nix packages. And over time, as the packages were able to build with that branch, the CI system, Hydra for Nix. Hydra is a CI system for Nix. It builds the branch over time, and it reports on the amount of packages that now build with GCC8. And once they all do, Nix package manager might switch to GCC8 by default. This Hydra CI continuous integration project is really interesting because it's basically a thin web UI on top of Nix, and Nix does everything for us. So this nice report was generated because Nix packages were modified on a Git repo. Hydra picked it up and built them. But Hydra can build a lot more things than just simple packages. It builds tests as well, and so this is how the Nix releases are tested. Every time something changes, all the dependent packages get rebuilt and retested before the release can be made. And so how's this done? We add tests to our Nix packages by specifying the check phase. In this case, the lean package comes with a ctest test, so I can just run ctest during the check phase. And if I do Nix build again, it will build everything, test everything, and I see a few test failures. So Nix log is a command that will take the result of a previous build and show you the logs for that build. So how do you do this? When you do Nix build, it gives you the path in the store to that build. And if that path can't be built, Nix log can go get the logs for it. And I see that the shebangs in these scripts for the test were not dependent on things being available in /user and /bin, which they're not on Nix. So Nix comes with a script called patch shebangs. Patch shebangs, if I add that script to the check phase in my package description, it will go over all the scripts in that folder and update the shebangs to point to the right, to the corresponding executable from the current environment. And that makes the test pass. Sorry? So things are symlinked into a folder, and that folder is added to the path. Nothing gets added to user or bin or anything that's global. Every user has a different environment. That,
It's not like a tree in
no, it's not. No, like you saw earlier, things are symlinked into ~.user environment, something like that. How am I doing on time? I think this is my halfway mark. Does anyone have the time? I'm good. Okay. Questions so far? Yes? Yes? Yes, it is. Nix build looks at the local folder for default.nix file. If you specify file in the command line, you'll use that instead. And then it checks the package. And in the case of our package here, Nix has a little bit of magic in it that detects that CMake is used as a build dependency. And because of that, it will use CMake and CMake-build to run the build. Yes, it does. If the dependency CMake in the build input here, what Nix does is it traverses all the build inputs and generates and puts the path for it in the include path and library path and etc. variables. And if the C compiler here is not present in this package, because this package uses the STVM to get built, this is the standard build environment in Nix, which contains the compiler and everything. And all that is put in environment variables or in the path so that tools can find it. No, you're not dependent on Nix as long it does modify the RPath of your executable, so they always point to the right library. Yeah.
The native build inputs, you mentioned CMake in Python there. Can you specify specific
Good question. Yes and no. You can't, every package has a single version, but for packages where there are differences between the versions, there will be a different package name for each version. So in the example earlier, we had Clang 6, Clang 7, Clang 8, GCC 7, 6, 8, etc. And auto tools and things like that also need different versions like that. That said, these packages, this language is a very powerful language. The package system that contains thousands of packages is a big fixed point over itself that you can modify with the override command. So there's a method on it called override where you can give it a package and override on that package the version, for example. And if the package is written in a way that it can be overridden, the entire system will be rebuilt, or not necessarily rebuilt, but it will now point to the new version of that package and you can use it. If the version is too different or the build system for that package has changed, it might not work. But in general, it's pretty easy to, if you need an older version, to go get it. By default, Nix has a single version for each package. And they can do that because of their powerful build system that rebuilds everything for every change and recursively. So they make sure that things build and that the tests pass. Okay, yes? How do you manage optional dependencies? Why don't I show you that later? I have a slide that will be able to explain that better. Yes?
If you don't run on NixOS, what are the requirements to set up a build of your dependencies?
Just run the installer. It should create, by default, it'll put the store in /nix/store. And then it might need to create users to run the builders, because each build runs under different users so they can't affect each other. And but you can run also Nix on a single user environment where there's a single user and it will run also very well.
Is it portable across virtualization?
Yeah, Linux, Mac OS, and Cygwin on Windows. Yeah. So this is my joke time. This is the one joke I have on my slide. So this is a NixOS logo, and I was thinking how it connects to C++. And my answer was, of course, it looks like a dream catcher, but it's made of lambdas, so it's a lambda capture. So that was my joke. So if Hydra is a thin layer on top of Nix, where does it get the distributed builds and the testing and all that? It's all been built into Nix. If I run Nix build and pass -- builders argument with an SSH URL, it will run the build on that host. But that's not usually done. I don't think it's even documented officially. You usually specify in your Nix configuration the list of build machines and how many packages can be built on them, some flags, architecture, and Nix automatically chooses a place to build the packages as it's building. And this is can be specified in the Nix configuration file, but this syntax here comes from the NixOS configuration, which generates the Nix configuration. But it's not NixOS specific, although it works a lot better on NixOS. And so how does Nix distribute things? Nix is a collection of Perl scripts that look like this. No, I'm kidding. Nix was Perl scripts, but for the past few years, they've been migrating to C++. They now require C++ 14. They're written with nice references and auto and for loops, and it's a very nice code to read, to go through. And something else you might want from a build system and testing system is multiple jobs. So for a single package, you'd have multiple jobs. And like building it with a different compiler, building it for a different architecture, et cetera, running different set of tests. So the way you specify multiple jobs is the first line of the package, instead of being just import Nix packages, you make it into a lambda that takes a few arguments. One of the arguments in this case is the Nix package set. So I can specify dependencies from a different architecture, for example, or the standard environment to build. So I can specify a different compiler and whether to run the checks or not. And I can add different arguments here, for example, optional dependencies. I can specify use boost, or I can specify use other things. So all the configure flags that your package might have, you can add them as parameters to your package and specify defaults, but then any user who wants to build it with different parameters can just pass those into the function. I say function because Nix is a functional language and a declarative language all mixed up together. And so your package is actually a function that returns what's called a derivation. And a derivation is something that describes your package with all the settings fixed. So I wanted to make multiple jobs so I can pass it to my CI server. I create a file called extra.nix that imports the Nix packages, and that imports my package in default.nix. And now I can specify different jobs. I call one job lean, which just builds the lean project. So it calls my package with the default arguments. And here I can specify a different one called clang, which calls my package and builds it for the clang compiler using the clang stdm by overriding the compiler in the standard environment. It can be complicated, but there's some nice documentation for it. And Nix has support for all these different kind of environments built in, and I'm going to show you a few. So now I build, if I pass -f to Nix build, I can specify the file I want to build from and the job to build. It builds with clang. We can see CMake detects clang. I can build with different libcs. So in this case, musl, muscle, is a different C library. I create an environment with that library, build it, and I can check in the log that it built GMP, one of the dependencies of this project, using muscle, and then it links to that. And it runs. I can do that for different versions of Clang. And when I saw this, I was really impressed. You can also do this for other operating systems. In this case, I create a package. I tell it I want to run this package in a VM for Ubuntu Xenile. And then I want to add these extra packages to the VM, CMake and libgmpdev. And then I just specify a small script that runs CMake and calls cpkgdeb to create a Debian file, Debian package. And it builds the package. It runs a VM. No, it's really smart. Because the build has to be in a sandbox, it can't run a VM that has Ubuntu Xenile, do an apt-get to install the packages because there's no network in the sandbox. What it does is it downloads deb packages, copies them to the VM, runs it with networking enabled. No, I don't think it needs networking enabled after having downloaded the packages. It runs the VM, it calls the configure and install phase for each of these packages. Then it closes the VM, takes a snapshot of the hard drive image, saves it to the Nix store, and then every time you want to rebuild your package, it takes that image from the Nix store, runs it, uses 9pfs to share your files with that VM, and runs your build script on it, and then extracts the result. And so here it is extracting the debs, booting from the ROM, mounting in the Nix store, and then it starts compiling the source, links, creates the package, and now I have a Debian package in my local Nix store that was extracted from the VM build. And so it looks like Nix packages has an entire half implementation of dpkg in it. And not only that, it implements wrappers or completely re-implements a lot of the logic for figuring out dependencies and dependency graphs for all these other packaging systems. I don't know if you can see, there's like Go, Java, Lua, Perl, Python, Ruby. And there's a few that are not on this list. For example, apt dpkg is not on the list. It can also install Emacs packages. When you specify to install Emacs on Nix, you can specify a list of Emacs packages to install as well. It will download them as a single step and then create a symlink mess of all these packages together. And when you run Emacs, they'll all be available. Yes? Yes, you can change in your package where the output is. By default, it's out. And in this case, it's not a directory, it's a file. So I copy it to a file called out, and whether it's a directory or a file, it gets added to the store. But in this case, it's called out in the build script. But once it gets copied out, the package has a name, and so the file gets renamed to the name of the package. And so it gets renamed to a .deb here. And not only does Nix wrap these other packaging systems, it also wraps your C compilers. So all the examples I had above that use GCC or Clang, they were a bit fake because they called Clang wrapper and GCC wrapper, which if we pass a Nix debug environment variable, will list the extra flags that it adds. So in this case, it adds the flags to find the path to the standard libraries and system libraries. And it also, by default, adds a bunch of hardening flags. So if you have a build error because you're not expecting O2 or these extra warnings to be added, you can disable them by passing the hardening disabled equals all environment variables. And it will act more like a regular C compiler. You can also create Docker images very easily. In this case, I just specify a name, a tag, the contents, which are a package, and Nix will get that package, all the dependency of that package, and put that in a Docker image. The Docker image will not contain Nix at all. I can specify Docker-specific commands. Configuration, so for example, I set the default command to run lean -- version. And nix build Docker will download Docker. If I don't have it, install it, set it up. You might need NixOS to get Docker to work. I'm not sure about that. And then if I load the result into Docker, I can run the image, and it's packaged with my project. There's lots of smart work that has been done also to, if you have really big projects, to generate the optimal layers for your Docker image, so that separate projects can depend on the same parent layers. I haven't experimented much with that, but it's very interesting how they do it. So we can also cross-compile. The first thing to do before cross-compiling is to change the native build inputs to use the build packages package set, which is the package on the build architecture, and the default package set will be the packages on the host architecture, the one we're going to run on. So I can build a package for Raspberry Pi by simply adding this line to my jobs file. And if I build it, I get a binary for Raspberry Pi, and I can run it using an emulator, and it works. Do the same thing for Windows from Linux using MingW. It will build Windows binaries. And I haven't done it in this slide, but you can also use Wine to run them. And so by adding jobs like this to a Nix file, you can create a set of things that has to be run in a CI or CR. And Hydra, you just point Hydra to a GitHub repo that has a Nix file in it. And every time the repo updates, it will rebuild what needs to be rebuilt, generate nice views, and you can click on it and get the logs. If there are HTML reports that are output by your tests, you can link them here as well. I think that's about it. So pros of Nix, it gives you nothing by default. Everything's immutable by default. It makes amazing build and test environments. And I haven't shown it here, but it makes for a pretty decent desktop environment. And it has a very powerful declarative DSL. The cons, there's a big learning curve, especially for the DSL, which kind of looks like JSON, but it's completely different. It has semicolons everywhere. There's no native Windows support, and there's a lack of documentation for advanced features. But considering the amount of features there's already a lot of documentation there. Any more questions? Yeah. Oh yeah, they're KDE, GNOME, Xmonad is what I used to use.
I'd like to specify that Mozilla uses it to clear Firefox. So the goal of that is actually to clear reproducible binary and artifacts, and actually choose that build environment to make sure that from the quality assurance, they are going to actually pick the right configuration to actually manage and create the bugs to actually reproduce what is the correct version where the bugs happen, and then they actually deliver the binary, and then the team will actually fix the problem on the correct version. So that's super cool.
Yeah, it has good GUI environment. There's also tests that test the UI environment before release. They run a lot of UI tests in that infrastructure. I've been using it for many years now on my personal laptop, and I just specify desktop environments in my global list of packages I want installed. It figures out which ones are desktop environments and adds them to the list of my login screen, and I can choose which one I want: Xmonad, GNOME, etc., Unity, and then it logs me into it, and works very well. It comes with a single. So what I didn't show here is that in addition to specifying packages declaratively, you can also specify modules, which are system services or other things like that, that depend on different packages and different files being somewhere in your system. And so in a single configuration.nix file, you can configure your entire system from the HTTP server, the websites, to the desktop environment, SSL keys, all that. And it manages the dependencies between the modules as well very well. For example, if in your nginx config file you add a port, you can specify right there if it has to be open in your firewall, if there's a firewall there, and things like that. Also, what's that website that allows you to get free SSL certificates? Let's Encrypt. You can add a single command, a single line to your configuration, and it will take care of that for you. Install the requirements, run the daemon, generate this SSL certificate in a certain path, and add that to your nginx configuration, things like that.
Do you know what the big random string of characters in front of names are and how they're generated?
Yes, that is the hash of the derivation. So once you build a package, packages are called derivations. So your package is a function that takes in a bunch of inputs and that generates a description of how it has to be built. And so that list of inputs, which are the hashes of the inputs and the description of how to build it, all that gets hashed. And that's where the hash comes from. There is an effort to have hashes of the content, of the generated content. That would only work if we had perfectly reproducible builds. But at the moment, I don't know if the effort works in Nix yet. Thank you very much. Oh, last question?
How was the error message?
Well, it depends. For Nix itself, there's a few arguments you can pass to the Nix interpreter that will make it a bit slower but give you exact locations from where theirs happened. There's also an alternative Nix interpreter called HNix, which has better error messages. But most error messages you're going to see here are error messages from bash scripts that are running in a sandbox that's being run by Nix, that's being run by another bash script, and all the levels can make the errors hard to figure out sometimes. But because Nix isolates everything from each other, the first step is to identify what layer, what box the error message comes from, and then inside that box, it's easier to find the source of the error. Okay. Thank you.